When we say El Nino, pretty much everybody now understands that we are talking about the tropical Pacific, and it's called a zonal mode because it's an east-west mode mainly, even though there are meridional or latitudinal signatures associated with El Nino. Other tropical oceans also have such a zonal mode. In the Indian Ocean, it's become known as the Indian Ocean Dipole, or IOD. There's a history behind it, but nonetheless, people, even normal people, ordinary people, lay people, now know that El Nino impacts may be negated by the IOD, even though there are scientific details as to whether IOD is independent of El Nino, whether that does something to the monsoon, or monsoon is responding only to El Nino, and so on. Nonetheless, there is east-west mode, but unlike the Pacific and Atlantic Oceans, the Indian Ocean has warmer sea surface temperatures in the east and colder on the west in a very seasonal way. Nonetheless, the thermocline has a slope, so it also oscillates up and down across the equator, which gives us the zonal mode, or the Indian Ocean dipole. In the Atlantic, which is much smaller than the Pacific as well, just like the Indian Ocean, has cold temperatures in the east, just like the Pacific, warmer in the west, and has a shallower thermocline in the east and deeper in the west, so also has a east-west mode, or a zonal mode, that is called Atlantic Nino. Okay, so all of them are kind of similar in terms of their basic mechanisms, but they are different in terms of when they reach their peak. El Nino, the big monster, peaks in December, January, February, and Indian Ocean Dipole typically peaks in September, October, November, and the Atlantic Nino tends to peak during the summer months. Okay, so is it a coincidence that DJF, December, January, February, is taken by El Nino, SON is taken by the Indian Ocean, and JJA is generally taken by the Atlantic Nino, and boreal spring season tends to be generally very noisy season. We talked about the flat sea surface temperature gradient and pressure gradient in the Pacific. We'll return to it later, but you often hear that forecasts of El Nino made before these months tend to be unreliable because the system is noisy and it can go in another direction. But during 2026, when the El Nino forecast was made, it was made very early on, and it has turned out to be true. But of course, 2024 was also forecasted to be a La Nina, but the La Nina didn't happen as expected. Okay, so forecasts can be very accurate up to 80%, which is very useful, but they can still be wrong 20% of the time. So let's look at the structure of the tropical oceans. We are, of course, used to the Pacific, the big monster here. We have east-westward push of the water, divergence, or waters moving away from the equator, and colder SSTs, warmer SSTs. Warmer SSTs spread into the Indian Ocean. It's often called the Indo-Pacific warm pool and not just the West Pacific warm pool. And we have monsoon circulation, which changes completely. So during the summer months, we have strong southwesterly winds, which produce strong upwelling in the west, and the thermocline is actually sloping the other way. You can see that this is sloping eastward here, so shallow here, deep here, shallow here in the Atlantic, deep here in the western Atlantic, whereas Indian Ocean is almost the other way, shallower in the west and deeper in the east. Okay, so you have also the Walker circulation. So you have the Pacific Walker circulation that we talked about. The Indian Ocean section of the Walker circulation is over here, and there is a piece of it also over the Atlantic Ocean, but the Atlantic is dominated by the rainfall over the Amazonia, which is the huge rainforest, but ITCZ is what connects all of them predominantly over here, but here we have the monsoon circulation. So because these oceans are smaller, the waves and the adjustments in the longitudinal or zonal directions happen faster in the Indian Ocean and the Atlantic Ocean. So the El Niños in the Indian Ocean and the Atlantic Ocean, i.e., the Indian Ocean dipole and the Atlantic Niño, last only about 3 months with some buildup and decay and so on, whereas the Pacific literally goes from 9 months to 12 months or longer. We'll see what takes that long. Warm waters have to come into the west and then move east and come up in the surface and create all this positive feedback that we talked about, that we will look at again, and then it has to decay away. Because it's such a large ocean, waves also move much slower, as we said, and everything takes time for the zonal adjustment, and the El Nino lasts longer, and much bigger heat sources being moved around, so it has real global connections, even though we always talk about IOD's impact on the monsoon. And there are nice papers showing also that the Atlantic Nino also has an impact on the monsoon. Then there are questions about what happens when El Nino and IOD work together, what happens when Atlantic Nino happens independent of the El Nino, can it still affect the monsoon, and so on and so forth. Many details, but the point is, because the oceans are bounded by the land and they have zonal contrasts, there are zonal modes of variability. So you have seasonal cycles and the zonal modes of variability, the El Nino, Indian Ocean dipole, and the Atlantic Nino are interannual modes of variability. That means they have an interannual time scale. We always talk about El Nino as having 2 to 7 year cycle. IOD is much more erratic, but now we claim that it's maybe happening more often. Atlantic Nino is also very erratic. So the basic question of whether they are really independent persists, and we don't know yet. Okay, so lots of nice scientific questions left wide open. We'll come back to look at the Indian Ocean dipole a little bit more, because we want to keep each podcast to about 5 to 7 minutes. Okay, see you soon.